Recording. Cool. All right. How you doing, guys? This is going to be lab 5. Okay, phase transformer calculations. You got the sheet from Mr. Sligers today in your instrumentation class, B1017. Mike Mankulich is doing the recordings right now. I'm going to run through all the process of the lab. I'm going to get you all the meter readings. Okay. Mike is going to record, and then we're going to scan it and put it on Financial Online for you. Okay, so you have your own results, and you can follow along with me with the lab here right now and understand the process of hooking up the transformer and looking at transformer loadings. So first part of the lab says connect the high voltage windings for 208 volt operation and connect the low voltage windings for the transformer for 120 volt operation. We did these connections last week, okay, when we looked at series and parallel configurations of the control transformer. All I've done with this transformer right here is I paralleled my H side of the transformer and I paralleled the X side of the transformer. Okay? I've input my 208 volts to this primary, and I'm now reading 124 volts, actually 126 volts on the output. Okay? First part of the lab says connect the high voltage windings to 208 volts. That's what I've just done. Okay, part number 3 says turn on the power and measure and record the current. This is the excitation current. You're going to do this again next week, but I'll show you why I'm doing it right now. This meter here is reading excitation current right from my source, right from my supply up top here. And all it's doing is feeding, the EMF in the transformer to get juices flowing and output my 120 volts on the secondary. What I've done is I put a 6-turn coil through that meter, so whatever value I see on this meter, it actually reads 6 times greater the current of 1 wire. So at this point in time, I read 0.65 amps. The reason why I put that coil on there, because these meters aren't really that awesome at measuring 0.1 amps, which is pretty much what you're going to calculate out to be for your excitation. But if I put a 6-turn coil through in there, or a 10-turn coil, whatever value I see coming from the meter, I just divide it by how many turns that I have. So my excitation current for step number 3, my meter reads 0.63, so you're going to be around 100 milliamps, somewhere in there. Okay. Then it says for step number 4, measure and record primary and secondary voltages. Meters keep turning off. Primary voltage, exactly 204. And secondary voltage, 125.2. Okay. Given that, I'm going to calculate my voltage ratio, okay, by dividing the primary voltage by the secondary voltage and figure out what my turns ratio is for my specific transformer here using my 204 and my 125. Okay. Mr. Mankulich, if I do that, I get somewhere around
1.629 to 1.
1.629 to 1. Awesome. Okay. 208, about 120 out. Now I'm going to go to my load bank. All right, and I've got a meter set up there for my load bank. All right, I'm going to turn the power off, and then I'm going to connect the Unitech load bank to the secondary of the transformer and turn on one 220 ohm resistor. There's my load bank right there, going right from the secondary of my transformer over to my load bank. Turn on one 220 ohm resistor, and I'm going to take some readings. So turn the power on, and using the clamp-on meter, measure the current flow in the secondary circuit of the transformer in amperes. That's coming over here. I have 0.52 amps of current flow. Okay. Then I go through and I look at step number 9, and I calculate the amount of primary current using the voltage ratio. Don't forget to add in the excitation current. Your excitation current was that 6-turn coil over here before. Okay. So Mr. Mankulich will do that calculation, and then I will tell you what the next step is when I look at the actual current flow. So step number 10 says measure the primary current and compare it to the calculated value. Okay, so I've got my measurement here, and I see 0.37 amps primary current flow. Okay, and Mike's got his calculated value for step number 9.
We can pause?
Yeah. Oh, cool, we can pause it. Okay, so we do the calculation, and we are reading 0.427. Calculated value for step number 9. Absolutely, right there.
In the red box.
And my red value, step number 10, measure the primary current and compare it to the calculated value. Measured value, 0.37 amps current flow, measured for step number 10. I'm pretty close, okay? So it says no load in this table here. It says step number 11, record your values in the following table for your findings of no load, 220 ohms, 110 ohms, and 73 ohms load. Cool. So I'm going to take my 220, I'm going to do no load first. And we've kind of done these values already on the first page, so that's okay. So I'll turn off my 220 ohm resistor, and my no load values, my primary voltage, 203.5. So I've dropped a half volt. No load value, voltage, 124.9. We'll do calculated voltage ratios later. Excitation current is going to be the same for all of your loads, and previous to that was about 100 milliamps. No load value, I'm not going to have a measured secondary current. That's going to be 0 amps, right? Even if I look at it over here, I don't have anything connected yet. All these resistors are still turned off. I have 0 amps current flow for a measured secondary. Calculated primary current using the measured and secondary and ratio. That's going to be excitation only, so that's around 100 milliamps. Okay. Measured primary current. Go back to my 10-turn coil, or 6 turns, I guess is what I had. Yeah, 100 milliamps, 0.63 amps times 6 turns through the amp clamp. Okay, that's my measured primary current, and then we'll look at measured the difference between your measured and calculated a little later on. Okay, step number 1: put in the 220 ohm resistor. And we'll start taking some readings. My primary voltage at 220 ohms of load, 203.5. Secondary voltage, 122.8. We'll do calculated voltage ratios later. Okay. Excitation current, that's still going to be your 100 milliamps, your 0.12, 0.11. Okay. Your measured secondary current flow, 0.51 amps. And measured primary current flow, 0.36 amps. Okay. We'll turn off 220, and we turn on a 110. And I'm going to see some major changes in this. I'm allowing more current to flow. So at 110 ohms of load, my primary voltage, 202.4. 202.4 for my primary voltage. Secondary voltage, 121. Ratios we'll do afterwards. Excitation is the same. Measured secondary current, 1.05 amps. Measured secondary current. And measured primary current, 0.7. It's bouncing around a little bit, 0.7. Okay, well, that's good for those values for that table. Now I want to do 73 ohms. I get a 73 ohm resistor by putting on a 110 and a 220. So at 73 ohms, my primary voltage, 202.1. Secondary voltage, 118.8. Voltage ratios we'll do later. 100 milliamps for your excitation. Measured secondary current, 1.55. And your measured primary current, 1.03. Perfect. Turn that off. Step number 12, we're going to rearrange our transformer a little bit. Okay. Very similar to last week, I'm going to use the X side of my transformer as my primary, and I'm going to use the H side of my transformer as my secondary. So I'm going to change my meters around just a little bit here, change my connections, and I'm also have to observe that I'm doing 120 volts on the X side of the transformer, not 208 like we did last week, generating 330 volts out of the H side, doing a parallel configuration that we did last week. So now I'm going to put 120 volts down to my X side, and I'm going to expect to see a certain voltage out of my H side, which is now going to be my new secondary. These guys all the same position. This is secondary voltage. Manual operation, meters are on, that's good to go. Excitation current. Ready to roll. Okay. Power on. All right. In this case, okay, turn the power on and measure the excitation current in amperes. I am 0.72 with a 1, 2, 3, 4, 5 turn coil on this time. Sorry, 5 turns this time. I missed one. Here's, now leave it at 5. Okay. 0.72 excitation, nothing connected just yet. Okay. Then step 14 says measure the voltages on the low voltage and high voltage sides of the transformer. Your low voltage side, I am reading 117.8, and my high voltage side, which is my secondary, 192.2. So we'll determine the low voltage ratio by dividing the high voltage ratio by the low voltage. Okay. Since the primary voltage, low voltage side is lower, the larger number will be placed on the right hand side of the ratio. Okay. And if we do that calculation, Mr. Mikulich.
to 1.63.
1 to 1.63. Perfect. Okay, turn the power off. Step number 17 says connect the Unitech load bank to the high voltage side or the secondary of the transformer and connect the clamp on ammeter to one of the lines and turn on one 440 ohm resistor. Right there, a 440. Okay, turn on my circuit. Okay, once I do that, turn on the power and measure the current in the secondary. My secondary current, 0.39. Okay. Calculate the primary current using the voltage ratio. Be sure to add in the excitation. And measure the primary current and compare it to the calculated value.
Plus excitation.
I get 0.636
Plus 144.
0.78.
0.78. And my meter is reading 0.75. Pretty close. All right. So the meter is step number 20, and the meter is reading 0.75 amps, primary current. Okay. So your primary voltage with no load, that was on the previous page. Okay, I can go back to that. Okay. No load, primary voltage, 117.7. Secondary voltage, 119.8. Or sorry, 191.8. Sorry, 191.8. My bad. Voltage ratios, we'll do those afterwards for you. Excitation current. Back to that. For 1, 2, 3, 4, 5. That was 0.74 divided by 5.
0.144.
0.144. Perfect. Secondary current with no load. No current. Okay. Excitation only. Measured primary current. .14.
0.75.
Oh, sorry. Yeah, 0.75 with 5 turns. What am I measuring now? I'm just measuring excitation now, right? Yeah, no load. Measured primary current, no load. We're at 0.78.
Oh.
Oh yeah, but that's the different side.
Oh, that was with the load.
1 second. There we go. Okay. Good. No load, measured primary current, that's only excitation. We're good. Okay. Put that 440 back on. Okay. Primary voltage, 117. Secondary voltage, 186.7. Voltage ratios we'll do later. Excitation current was the same. Okay. Measured secondary current, 0.39 amps with a 440 ohm resistor on. Okay. Calculating my primary current,
0.78.
0.78, and I'm reading 0.75. Okay. Well, that's good. That's with 440 ohms. Now we'll do the same thing with a 220 ohm resistor. Okay. Primary voltage, 115.9. We're getting a little lower here. 115.9. Secondary voltage, 181.6. 181.6. Calculated voltage radio, we'll do that later. Excitation current is going to be the same the whole way through. Measured secondary current, 0.78. Measured secondary current, 0.78 amps. Calculated primary current, we'll do that for you in a second. And measured primary current, 1.4. Measured primary current, 1.4 amps. Okay. So just give us a second here, guys, and we'll get some numbers for you. Okay, guys, Mr. Mikulich and I have finished off the calculations. That's coming on to Fanshawe Online for you in just a second here, probably about the same time this video does. Watch this video, and then please do not forget about the Fanshawe Online quiz. Keep an eye on your email for future direction and things that are coming up, and more communication from Mr. Mikulich and myself. Thanks, guys. Have a good afternoon. Talk to you soon. Bye.